Well, good morning, everyone. My name is Mark Burgess, and we're going to talk about CFEngine in a day. CFEngine is my fault. I wrote it back in 1993, and it's been rewritten several times since then. Most recently in 2008, when we rewrote the whole of CFEngine again from scratch almost to refactor code that had grown old. So now we have an almost completely new CFEngine with language redesigned, and here we are talking about the latest and greatest. So imagine a world in which computers are everywhere. They're in your pocket, they're on the desk, they're in the walls, they're in your refrigerators, in the TV. This world, I think, is not so hard to imagine because it's the world we live in today. Although when I wrote CFEngine originally, it seemed still like a fantasy world. But today, computers are really everywhere, and increasingly, the operating systems being used are Linux, a little bit of Windows, but Linux is cropping up everywhere. Last year, I bought a new Philips television, opened the box, and out fell a copy of the GNU public license. Linux is everywhere. My new hi-fi system has a Linux machine built in, managing the disk storage. Linux is everywhere. All of these smart operating systems need to be managed. They need to be updated, they need to be configured, and that requires some sort of technology. I like this quote by Mark Burgess: "The most profound technologies are the ones that disappear. They go into the walls with the electricity and the sewage. They weave themselves into the fabric of everyday life until they're indistinguishable from it." So when a technology matures, we really don't see these machines anymore. Originally, of course, when I was at university, I used to have to sign up to a list to get a seat in a room where I would go and use the one mainframe the computer had. And now, of course, there are workstations, there are PCs on the desks, and eventually these things are disappearing. In a few years' time, we'll just have pads built into the desktops where we're working. All of these carrying devices will be gone. So all of this technology is going to disappear from view, and in order to make that illusion happen, we need a fabulous infrastructure buried in the walls along with the electricity and the sewage. And that is what CFEngine is about. It's about making that technology hands-free. It's about hiding it in the walls where we don't need to touch it anymore. Throwing away the keyboard because we no longer want to be hands-on making changes to computers. And that was the dream back in 1993. It's still the dream today. We've made some progress, but in fact not as much progress as we would have liked. Computing is changing, of course, and in that environment of change, a lot of improvements have been made. So the problems we were solving or trying to solve in the 90s with configuration management, some of them are still here today, but some of them have been solved and have been absorbed into the technologies themselves. So operating systems are much smarter than they used to be. We don't have to fix DNS usually used to be a big problem. Now it's not so much of a problem. User management used to be a huge problem. Different ways of doing user management today. These things get easier over time, and they get absorbed into the layers of technology. But there's always some sort of layer at the top of the stack where things need to be managed. Today, system administration is increasingly about applications. Application management is probably the most important challenge that businesses face. And it's because, of course, everything is online. Data centers are not just providing platform for people to use PCs anymore. They're actually delivering online applications with integrated databases and multiple systems orchestrated to provide online services. And to build all of this up from scratch requires a lot of effort and coordination. Those complex coordination problems are the kinds of problems that we're trying to solve today. So you've all heard about cloud computing, and this is This means different things to different people. In fact, when people talk about cloud computing, they're often talking about things that happen in data centers. On-demand, disposable computing. To be able to re-provision machines, use them for a purpose, throw them away, reuse them for something else. This, of course, is a good thing. But I would say that the real cloud that we're talking about is all of us, with our mobile devices, with our pads and our PCs, our wireless networks. That is the real cloud. Everybody using the computing system together, making that whole system work by creating a fabulous infrastructure that makes it all happen seamlessly. That is what the cloud is really about. And that's where CFEngine still has a role to play. So I stole this picture from the web. You see some kind of a picture of layers of infrastructure. So at the bottom we have the hardware. In the middle we have some sort of operating systems. And then increasingly virtual layers, virtual machines coming into play. And then at the top of all of that we have custom applications. These custom applications are where the real action is. But still, at the different layers, there's a need for configuration and automation to make this infrastructure fit together in a seamless way. And CFEngine can be applied at each one of these levels. But increasingly we would like the stuff that happens in the middle to be just fixed, done, hidden, taken care of, and then the kinds of things that we adjust on a daily basis are at the top and the applications. So, to another point, which is about the way IT management has been done over the years. And if you look at statistics online, it turns out that IT management is a very project-oriented business. We set up these big projects, and the depressing news is that 50 to 75% of these projects actually fail. They fail to deliver what they're supposed to. They fail to deliver on time. Some of them don't deliver anything at all. And I liken this situation to rocket science. I call it the rocket science approach to IT management, because you spend months or years setting up a project with 90% overhead to deliver maybe 10% value at the end of it. It's payload at the top of the rocket. And it has a deadline, some launch date, and you launch this thing on this date, and either it works or it doesn't. Maybe it blows up on the launch pad. And then you just have to pick up the pieces and start all over again. You go from rocket to rocket, starting from these big projects, lots of people involved, very expensive, and not very agile. It requires planning overhead. You get one chance to get it right, and it's a huge, risky rollout. It's a huge, risky launch. So it's a high-risk way of managing systems. We want to get away from that. We want to try to reduce risk and make things safe, safe and reusable. The 747 is, if you like, an icon for what businesses do. And the genius of business, in my view, is that business will take something like rocket science, where lots of experts are involved building these specially crafted devices, and they will turn it into a craft which is now reusable. It can be mass-produced, it can be reused. If it no longer wants to fly to one destination, it can be flown somewhere else. It can be adapted to carry people or to carry cargo or anything you like. In fact, this is an extremely versatile, adaptable, reusable way of flying. Much better than a rocket. You don't have to train astronauts for 2 years to fly it. You just swipe your card and you walk on, take your seat. So we would like to turn computer science, IT management, from rocket science into aviation, 747s. We would like to commercialize it in some way, make it reusable, adaptable, agile. And that is also part of what CFEngine is about. So what is CFEngine? Well, it's a lot of different things. It's a framework for managing systems, for automating systems, but it includes a language. And some people perhaps think that languages are outdated. We've gotten used to menu-driven user interfaces. But of course, menus are not that not that useful for customizing or doing detailed engineering work. And IT infrastructure is still an engineering task. When you go to a restaurant, you can't really point to the menu and click on it and get the perfect steak. If you want really the perfect steak, you have to use language to explain exactly how well it should be done, you know, how it should be salted and how many minutes on each side it should be fried. You need language to explain that stuff. And in the same way, we need language to explain exactly how systems should be configured. So CFEngine includes a language environment for explaining exactly how systems should be set up and configured. But it does include other things as well. It includes, in fact, a simple monitoring framework. It turns out that it's a... Oops, we lost the sound. Can you guys hear me? Yeah. It includes a simple monitoring framework which allows you to create feedback between what you observe the state of a system to be and how you would like it to be configured. So just as aircraft have self-correcting autopilot systems, so CFEngine has sort of sensors, detectors, and it can adapt the behavior of the system to the current state and bring it back into some sort of policy compliance. Ultimately, CFEngine is a knowledge resource. We do a division of labor, separate the work of humans from the work of machines. Things that humans are good at, thinking, planning, strategizing. Things that machines are good at, consistently implementing repeated actions. Sometimes people say that by bringing in robots into the workplace, by automating things, you dehumanize work. But Alvin Toffler in the 1960s argued that this is wrong. He said that what is dehumanizing is asking humans to behave like machines in the first place. By asking humans to hands-on with the keyboard, make lots of manual changes to computers, that is a dehumanizing thing to begin with. But we can replace that process by making all of that hands-on stuff replaced by machines, and then humans can manage the knowledge at the end. The challenges we face include scale, complexity, application management. It's about huge data centers. It's about complex applications in very complicated companies, often with many departments running different teams on different systems, all have to interact together. That complexity requires a lot of knowledge to keep it under control. So the ability to manage knowledge in this system is in fact a key part of IT management. And CFEngine should be thought of as knowledge management as well. So CFEngine is a framework, a tool for making this happen. And it's now being reborn. It's in 4 versions. Eventually it will be the Community Edition, which is the free open source downloadable version. We have Nova, which is the first commercial edition, which adds sort of business-like features that are valuable to businesses, reporting and so on. And then Constellation will be released this year, and Galaxy is far, far away in the future. So what is special about CFEngine? There are lots of management systems. When I started, it was just RDist, just for squirting at the toothpaste approach to system management, just or the fire hose approach to system management. Squirt systems with an image. CFEngine is a full maintenance system. It's not just a rollout system. It's not just about building machines and deploying software like a rocket launch. It's a reusable maintenance system like a 747. It can be, you can fly back and forth many times to the same location without blowing up your device. It's self-healing in the sense that if you find yourself not in compliance with your view of how the system should be configured, it will correct the system in real time and bring it back to the ideal state, back to a compliant state. This is very important today in business where systems are expected to comply with commercial governmental requirements, Sarbanes-Oxley, PCI, DSS, credit card regulations and so on. Many, many kinds of regulations imposed on companies and organizations. Systems have to be compliant all the time. If they move out of compliance, they need to be fixed immediately. So instead of making an alarm and asking a human to come and type on the keyboard, we can now just leave this, push this into the walls and allow the system to heal itself. So this maintenance can now be pushed into the walls along with the rest of the technology, and it can become part of the automated infrastructure. So self-healing, we call this convergence, bringing the system towards a consistent ideal state. Self-monitoring, so the system is looking at its internal state continuously and repairing it continuously. And feedback, of course, makes this possible. CFEngine is about being very lightweight. Many management systems are huge frameworks, megabytes, hundreds of megabytes of packages and code that need to be installed to do the simplest of tasks. CFEngine is about 5 megabytes, I believe, in total. It's written in C, it's very small, it's very lightweight. And this is important, I think, especially today when we're trying to get as much out of computers as possible. Building virtual machines on top of physical machines for green IT, to be able to maximize the power usage of a system, to be able to get the most computing power out of the hardware that we have. The management system should not be making a huge impact on the system itself. So CFEngine should be very lightweight, very fast. If it's fast, it means we can run it often. If we can run it often, then we can correct errors in real time. So very important that it's lightweight. Versatile, it has to be versatile, just as a 747 can change course, fly to different locations, remove the seats, put in cargo. We can configure CFEngine in any particular way to change a machine from one purpose to another. So the ability to adapt and change the purpose of hardware, this of course is the key to the cloud. So throw away systems, rebuild them, reuse them, recycle all of your resources. And the other thing about CFEngine is it's not just an ad hoc approach to management. It's based on some theory which we've worked out over the past 20 years, based on really the best of the research we've been able to do in this area, and tried to apply the principles that we've learned, the lessons that we've learned from configuration management, and try to do the best possible job for the problem. So before we dive into the details of programming in CFEngine, let's just point out a key difference between the way CFEngine works, or convergent self-healing approach to management works, and traditional scripting. And I use these two pictures to illustrate the difference. On the left-hand side, we have what we'd call traditional scripting approach, where you start out from some baseline state, base camp, if you like it. This is a picture of Everest, if you didn't realize. So base camp is your bare metal installation, you install your operating system from the CD or whatever. And from that point, you start running scripts in a particular order. First, you install package X, then you install package Y, then you change this file, and then you set some permissions, and then you do something else. And you follow this very specific path, and you reach your ideal state at the top of the mountain by climbing up this hill of changes. The problem with that approach is that if anything goes wrong along the way, if anything goes wrong, your recipe no longer works. It will take you somewhere else. You won't reach the top of your mountain. If a little avalanche happens here, then you may find yourself at the bottom of this valley instead of at the top of the hill. The other problem is that if you then repeat your recipe for some reason, it in fact takes you somewhere else entirely. So your recipe is a set of relative changes from your baseline, your base camp, which takes you to your ideal state. You can't repeat that, or otherwise you start undoing the state again. So traditional scripting is fragile, first of all, to unexpected changes in the environment, and secondly, to people executing these scripts multiple times. So the way we do it is we turn the mountain upside down and throw ourselves off the top. And then you roll down to the bottom of the valley, or it gets sucked into your black hole or golf ball hole or whatever you want to call it. And if you were to come out of compliance now, you simply roll back into this ideal state. So we try to arrange the technology in such a way that it behaves in the way of a black hole. Notice that it's also independent of where you start from. So it doesn't matter if you start from base camp, or if you start from another hill, or if you start from base camp plus halfway up the hill. No matter where you start from, in this convergent approach, you will end up in the ideal state. So it's insensitive to the initial state. That's important, because we don't necessarily know what the initial state is always. And if we get out of compliance, if something goes wrong, somebody messes something up, we can always know how to bring the system back into compliance. So those are the two properties that are important to be able to push automation into the walls, to be able to take humans out of the loop. So one thing that we can say about CFEngine is it's about solving complex business problems. And I say business problems because most people running computers are, of course, businesses, but it doesn't have to be a business problem. It could be a public organization. The problems are the same. What characterizes IT management today, though, is that a lot of the problems are quite complex. We used to create an infrastructure for people, which was, you give them a PC, and then you leave them to install the programs themselves. Or you set up a PC with a few basic applications, and everybody has to use the same applications. It used to be all about making all the machines look exactly the same. That's no longer good enough today. What businesses are trying to do is to make many machines different. A friend of mine at IBM in the US said he uses CFEngine in a data center with 800 machines. That's not so many machines, actually, today. 800 is not so big. But every one of those machines is different. Whereas many people have been looking to make, the huge data centers, the Googles of the world, all of their machines are pretty much the same because they're doing a cluster kind of application. But in many organizations, they have specially tailored applications, specially tailored services that make all of these machines quite different. And that is the challenge to manage. That kind of diversity of a functionality of applications, that is what we're trying to solve in today's problems. And to solve these complex business problems, we need a language interface. And this is where CFEngine comes into its own. So to be able to solve general problems, we need to make the language sufficiently low level. If we make the language too high level, we end up hiding details, making black boxes, and then you can't open these boxes, and you find you need to. If the approximation is too simple, we won't be able to solve the complex problems. So we have to start with some fairly low level to be able to adapt to multiple challenges. But then we allow, on top of that low level set of primitives, we allow you to build interfaces that hide some of those low-level details and make nicer interfaces to be able to use. So this is the strategy in CFEngine, to give you a set of low-level tools and then to give you multiple ways of making interfaces to make it look nice, to hide those details underneath. And the idea is to do it without you having to program yourself. So in some management systems, they'll give you a high-level view, and then they'll give you a programming language to say you can extend this yourself by programming. In CFEngine, we don't expect you to do programming. We give you a low-level language and then allow you to simplify it yourself in a way that suits you. What this allows you to do is to manage systems in a very flexible way. You can have multiple overlapping areas of your IT management. So you may have the Department of Computer Science, you may have Department of Physics, Department of Chemistry, they're all rather different. CFEngine started out in a university environment where everybody is special. In universities, everybody is special. Nobody wants to be put into a single framework. So we need this great freedom. We install CFEngine at a lot of banks. Banks are often, and and large companies where these companies have been formed by absorbing other companies, buying up other companies. So these organizations end up being lots of pockets of quite different cultures who've done things in quite different ways that are suddenly expected to work together and cooperate. And it used to be that they would try to then restructure the entire company and force everybody to use the same system. Increasingly, the speed and the complexity of this is increasing, and it's just not possible to do anymore. So you have to give up and say, everybody can do whatever they like, and we try to make it all work together. And CFEngine is good at doing that because it can adapt to these different environments. We call this federated management, a federation of loosely connected parts that can work together. So we have great freedom to choose these things. The final thing worth mentioning is maybe this notion of DevOps, which is, you may have heard of. DevOps has been talked about quite a lot over the last couple of years. And no one's quite sure what it means, but the idea is, I think, that today's challenge is to create complete running applications from bare metal, automate the entire procedure, and deploy these tools automatically without human involvement, and to make it all automated and fast and efficient. So there's some development involved, and there's some quality assurance built into this process, which makes it somewhat like code development. But it's also operations because we're implementing. So somehow it's a mixture of developing and coding and implementing from the bottom up, from the lowest, from the hardware level way up to the top level of the application itself. So this is what CFEngine is about. It's what it's good at. It's a framework. It's about being able to describe the whole problem from the bottom up. So how are we going to get started? Well, it's huge. We could talk about CFEngine for a week and still not cover everything. But we only have a day, so we're going to go rather quickly. And there are two ways we might approach this. We might try to hit the ground running, as the Americans would say. Just get into it, start with some simple examples, get it working. Start from the top down. We don't want to think too much about the details, learn all of the details of the technology, just get it working and see and learn over time. We might also try the opposite approach, try to learn everything possible about the language so that we're absolutely certain we're not going to make any mistakes, and then try to start constructing everything from scratch after that. I don't recommend the second approach, although some people try to do this. My thinking is that it's better to get started rather quickly and then convert this, because the second approach is rocket science. Yeah? You wait, you invest a lot of overhead in learning, and then you start out trying to launch in one go. Much better to get the thing running and try and fail, or see how far you get. So there are also two aspects to CFEngine. We can study the simple use of it. We can install a package, for instance, from CFEngine website, or we can compile the code and get it running. And we can learn the configurations by example. This is the top-down approach. And we can study the language in detail, jump into the coding, learn all of the syntax, and that's the bottom-up approach. So we're going to try more of a top-down approach today, or at least some sort of hybrid between the two. And hopefully you will end up with an impression of what you can use CFEngine for, and you will see where to find information on our website about how to get started. Ultimately, what we're trying to do is to find a method of working in a scalable way to configure computers. So we want to take an issue, a configuration issue, installing software, building a cloud, running an application, and we want to turn this into a set of maintainable promises about the system. In CFEngine, everything you say is a promise, because a promise is something that can be kept and can be kept over time. It can be maintained, not just installed once, but maintained. So we might promise that the password file will contain a certain number of users. We might promise that the shadow file will have certain permissions. We might promise that a web server will be running and that its document root will point to a particular directory. And we might promise that, SNMPD is not running or something, which would be a very good thing, in my opinion. We want to make certain promises about the way a system should be, and this is a definition of our ideal state. So everything is going to be a promise, and CFEngine's job is then to keep these promises on our behalf. So we basically want to turn our description of the system into a promise, or a set of promises, and CFEngine will keep these things. We code these promises in CFEngine in the CFEngine language. The motivations for this, of course, are business integration. One reason for talking about promises is that business people, of course, don't know anything about configuration management. But they are increasingly interested in how IT management is run because businesses depend on IT. There's a huge gulf between business people and technical people. And this has several consequences, of course. Business people don't have insight into IT, so they tend to ignore IT people. It gives IT people low status in companies. Low status means low wages. So if IT people can communicate what they're doing better to business people, they rise in their estimation. They become more important in the organization. And business people become very happy because they have some clue that what is being done is supporting their business needs. So aligning business and IT is a very important thing today. As I travel around the world talking to different companies using CFEngine, this is one of the main challenges people are facing today. Apart from all the cloud stuff, apart from all of the application stuff, it's about linking business and IT management together more closely because people need the assurance that their business is being taken care of. By coding promises in a document and having them implemented automatically, by being able to tie those promises directly to business goals, you are actually communicating with your business management, if you like, what it is you're doing in the IT department. And this is of huge value to organizations. This is part of the stuff we sell in the commercial version of CFEngine, this assurance. The other side of promises, of course, is that promises are reproducible. Once you have documentation of your state, it can be reproduced. And, of course, by adjusting these promises, you can make things quite agile. So everything in CFEngine becomes a promise. That's kind of a principle. Now, we're going to look at some examples of the code. And if you download CFEngine from our website, you'll find that in the tarball, in the bundle, you'll find a bunch of examples. When you install the software, these things get installed in user local share doc CFEngine. And this directory contains lots and lots of examples called unit something or other, unit tests, units, examples, which can be run as it says on the slides here in this way. We run the agent, which is the active part of CFEngine, and -f means read in a particular file, and then we run the example like so. We can also run the examples in verbose mode, which shows a lot of details about what is going on, and that will give you some insight allow you to learn about how CFEngine works more. I will show you, or I will point out some examples as we go on today that you can try. We won't have time to try them here, but you can go away and try them on your own, or you can try them here and now if you like. Pardon me. Small digression. If you want to install CFEngine, there are two approaches. The top approach is the classic open source, download the source code, configure, make, install, to install the binaries, and then you have to run this command CFkey, which generates secret keys somewhat like SSH keys for the encrypted data transfer. And then you should copy the CFEngine binaries, which get installed in user local sbin, into a special cache, CFEngine work directory called var CFEngine bin, and then you're ready to go. Then you simply run CFEngine, and this is the main part of the software. The alternative is to install a package from our website using RPM or Deb or whatever your favorite package manager is. You simply install the RPM, and then you run CFEngine with some sort of bootstrap command line, which will start the thing running. So these are two approaches to installing the software. And once you've done that, you should be ready to go with trying it all out. So again, we can go top-down or bottom-up in learning CFEngine. By top-down, I mean we can look at things in terms of services, configuring IT with regard to, are we setting up a web service or a database service, or are we configuring an application? That's one way of looking at it. Some people would rather look at it from the opposite point of view, which is to start with the basic resources of the system, the password file, the services file, certain packages, and so on. And increasingly, I would recommend people to look at it at configuration from a service-oriented point of view, simply because this is the best way to align with business. Business thinks in terms of services. If you go up to your manager and say, okay, I added 2 lines to etc password, they'll probably look at you a little bit strangely and think, I'll do my best to never meet this person again. This person speaks a different language. Whereas if you say, well, I managed to set up the web service and it's running and I've guaranteed that it will never go down, then they will probably be quite happy with you. So this is a good way of communicating actually between business and IT by taking a kind of a service-oriented approach. So what do we mean by a service-oriented approach? Well, let's take a look at a little demonstration. So this is just a screen capture of a very simple demonstration about how we could set up a machine as a web server. So this is on an OpenSUSE machine, so Zipper is the local package manager. And we just start out by removing the web server from the system just to show that it doesn't contain a web server. This is doing stuff by hand, which we shouldn't do. We should never do this at home, kids. But now we see that there's no web server running on this local host, and we now want to repair that. So our policy is about installing a web server. And at a very high level, this is a CFEngine configuration. We see we can make the configuration really rather simple by saying basically web server on, web server off, web server on, and hide all of the details of the configuration at this level. We can run CFEngine here, and you see it. CFEngine talks to the local package manager and starts installing packages to make this happen. All of these details are programmed into it somehow, which we'll see in a moment. It starts interacting, installing these packages, and it will set permissions, configure the document root to point to the right place, and you see eventually it will start the Apache daemon. So we should now be running a web server. So we go back to the web, reload the web page, and we see the system is now running a web server. So we now go back to the policy and we say web server off, and we can change our minds. We say we don't want this machine to be a web server anymore. We want it to be taken down. Run CFEngine again. It will now heal the system, repair the system by shutting down the HTTP daemon. And again, it's gone. It's no longer working. It didn't remove the packages. We could have asked it to do that as well. Now we can change our mind again. We switch it on again, and so on. This is kind of cheating. We've hidden all of the details, but this gives you some impression about how simple it can be if you're thinking in a service-oriented approach, to just simply set up a service and talk about having that service available. So that's one way we might try to manage the knowledge of running a service like a web service. So one thing that CFEngine can do is to bundle things like services into kind of subroutines, if you like, and then we can simply call these subroutines with or without parameters. It's entirely up to us how we decide to make these things, and build different kinds of abstractions to managing the system. Service-oriented is good because services are business-related, they're application-related, and that's kind of the way people are working these days. On the CFEngine website, you will find something which we call the Orion Cloud Pack, which was a set of managed services for basically setting up web servers, databases, programming languages, all of the kind of regular things that you want to set up for basic use of systems. And you can make these things work simply by switching on and off bundles like this, like we did in this example. So that's one way of making things work. The other way we could do it is by trying to manage resources. Resources like the password file, or in this case, Windows. If we look at Windows computers, and CFEngine will run on Windows, you have the registry. And things like the registry are harder to manage because they're sort of closed devices. You know, text files are somewhat easy to manage because they're free format, but databases are rather harder to manage because they're closed. You need special tools to manipulate them. And if something is messed up in a database, it's often hard to fix. Again, because it's hard to see, to begin with, to see what's actually going on inside. But we can also do that with CFEngine. So if we look at a second little demonstration here, registry, the same kind of idea as the previous example. This is, of course, the Windows registry editor. Probably nobody uses Windows here; it's so old-fashioned, but we'll give it a go. So this is a CFEngine script, quite low level now, which is going to install some CFEngine AS key in the registry. And we can simply run CFEngine here, run CFEngine on this Windows machine. Here we go, we type in the command for this special script which you just saw. And now we reload the database here, and we see that the CFEngine AS key has been installed in the registry. Very simple, low-level approach to managing data in this database. And this is what the thing looks like. So now we could add some data. We could add value 1 and value 2 to this key in the registry. So getting even more detailed now. And we run this example, and we see CFEngine repairs the value because it wasn't there from before. Reload the database. And now we see there's a subkey, and now we see value 1, value 2 inserted into this database. We can cache the state of this database as well to some extent, learn what is inside it and remember it. So here we're going to scan the Adobe key, because if this database should become corrupted, then we can actually repair it if we measure its state. So there's the Adobe key, and now we're going to use this script, which is going to restore values from the key. So let's try to start, first of all, Acrobat. Here it goes. It starts quite nicely because the registry is okay. Stop this. Now let's delete the Adobe key. This will break the application. It won't be able to start anymore. So if we now try to start the Adobe Acrobat, it doesn't work. And Windows starts to try to repair it, but it can't. so we can't start the software. But now we can run CFEngine with a restore function, and CFEngine will now restore the missing keys. Reload the database. There we go. It's restored the database. And we can now try to restart Acrobat Reader, and it starts again. So we can learn, we can scan the system to some extent, learn its good state as well, and restore, that's the word, restore the state of the system based on that learned state. This is quite a useful thing. And in case you think this is just a peculiarity of Windows, in fact, a lot of systems are moving in this direction. The Macintosh is moving increasingly in this direction, having private databases that have to be managed through command line interfaces and so on. Yeah, question back. Right, so the question is, what is the difference between simply having a backup and having CFEngine learn the state of this system? The main, of course, to some extent, it is a backup that CFEngine is taking and learning and restoring. But by having CFEngine take this backup and be able to check the state in real time, by real time I mean every 5 minutes or so, if this gets damaged, CFEngine can restore the state before anything bad happens, before the system is rebooted, for instance. Windows, sort of the gut reaction is to reboot the machine when something doesn't work. But sometimes if the registry gets corrupted, rebooting the machine may result in a machine which will no longer boot. So one advantage, of course, is to have this automated repair, is to fix problems before they become so critical that you really get into a pickle. So that's one answer to that question. So in the commercial operating systems, the Mac and Windows, these databases are increasingly used to store special information. And so this approach to management is also something that we have to take seriously. For dealing with resources in CFEngine, we have a special library, which we call the COPBL, the Community Open Promise Body Library, which is basically a collection of methods that you can use and reuse for configuring systems using simple interfaces. The idea is to have a standard library of ways of fixing problems on machines, a lingua franca, if you like. And that's nice because it allows us to standardize, have a common language for communicating with people. So if one company goes to the website and asks a question, the other person will be able to reply with a standard kind of approach to doing things. And so this builds the community part of CFEngine, which, of course, is the advantage of open source, having these communities of people who help each other. So these are ways of using CFEngine: service-oriented, low-level, resource-oriented. The key points are that CFEngine will not just install these things once, but we'll be able to repair them over time. Something goes wrong, a repair can be made automatically, hopefully before anybody even notices. So let's look at some of the basic tools in the language and see what a CFEngine configuration actually looks like. The examples I'm going to show you, I'm going to strip away some of the code, and the bit that I'm stripping away is the bit you're seeing now on this screen. So if you want to try these examples, basically type in these lines and paste in the examples here where I've written the example comment. Every CFEngine program has what we call body common control, or a control part, which has a sequence of bundles. Bundles are like subroutines. This is one bundle. We call it main, like in a C program, for why not? We can call it whatever we like. And we put this bundle in the bundle sequence. And the inputs list contains a number of files that we want to input or read in. In this case, we're going to read in the COPBL standard library, which is called CFEngine standard lib. I've used some color conventions here to make it easy to see what are language words and what are user-defined words. So anything in red is a CFEngine word. It's part of the language. Anything in blue is something that you would define yourself and can choose. And then anything in black is sort of user-defined data, which becomes part of the promise. So this is the framework, and we're going to stick examples into this. Everyone okay? Makes sense? Some kind of sense. Okay, so let's run through the basic kinds of promises that CFEngine can do. And this is now going to fairly low-level parts of the language, the lowest level parts of the language. So the first kind of promise we can make is about files. Files are obviously pretty important things on computer systems. And to create a file or a directory, these are the kinds of promises that we might want to make. These are just examples, of course. It can become as complicated as you want it to be. There are many attributes of files that can be set, but this just gives a simple example. So to create a file in the directory home mark temp called test plain, I can write a promise like this. And you'll notice CFEngine word perms, which is short for permissions. And then user-defined term MOG, which by incredible powers of intuition you managed to understand stands for mode owner group. We could have called it my permissions or Fred or whatever. But we call it MOG, so it's easy to remember. And this has three arguments: the mode, the owner, and the group. Now I could have designed this differently. I could have said permissions points to defaults, and then defined defaults to contain 644 root and wheel hidden away somewhere else where I don't have to see it. But this becomes part of the strategy of knowledge management in CFEngine, where you can show certain things and you can hide certain things. Sometimes it's good to see those details. Sometimes you want to see those details. Sometimes you don't want to see them at all. So it's up to you as the designer of this configuration to say, do I want to hide this information or make it explicit? And this is part of communication, actually. To whom are we trying to communicate when we write this promise? Well, this is a standard way of doing it. I think this is a reasonable compromise. A lot of the details are hidden in the standard library. And of course, the magic word is create, true, which means that this file will be created, and of course it will be created with these permissions and owners. If we want to create a directory, then we just leave on the trailing slash to say that it's a directory, and you can put the dot afterwards as well, just for good measure, so you can see it easily. And again, the same permissions will be set. One caveat for permissions of directories is that the default behavior in CFEngine is that if we've set the read flag, then the execute flag gets set automatically, because normally the execute flag should be set so that we can enter that directory on Unix standard. So that's the assumption. Of course, you can change all of this behavior in as much detail as you want. Those details are hidden in the definitions of MOG, amongst other things. So these are two promises, and we would paste these into this example here. We would then run CFEngine, as I showed you on the previous slide, and magically these files would be created with the correct permissions. If we remove one of these files, CFEngine would recreate it. If we change the permissions, CFEngine would change the permissions back without altering the contents of the file, and so on. So each part of these details is managed independently by CFEngine and brought back, like rolling back into this black hole. No matter which way we deviate, it will always roll back into this specification, this promise that we've created. We can copy files from one location to another. So copying a single file here to a location. Notice that in both of these cases, the first item in these promises, in quotes, is the affected object. So when we're copying to a file from a particular location because the file we copy to is the file that gets changed. It's the affected object. So the first thing is always the affected object. So we're going to affect test plane. It's going to be a copy from this $sys work directory /bin/file, which is presumably a Windows machine, or we're copying a directory from $sys work directory bin. This dollar thing, of course, is a variable which CFEngine will substitute. And in the second case, so in the first case, it looks like we're copying from a local disk to a local disk. On the second case, we're going to copy from a remote host, and secure probably means it's going to be encrypted. So again, the red things are CFEngine words, the blue things are user-defined words, and in this case, these local CP, secure CP, are in the standard library. It turns out that to copy a file, there are like 200 different options you might want to have, like should it be encrypted, should we keep a backup of the file, should we change the permissions of the file, should it be over IPv4 or IPv6. Dozens and dozens of options, and all of these things can be set within CFEngine, and all of those details have been hidden in this local CP template. So we have creating files, copying files. We can also copy whole trees of files, whole directories and subdirectories, in which case we add this depth search directive or part of the promise. So we promise to copy from the same directory, and we also promise to search the depth of the directory, go deep into the directory, and search recursively in the directory and copy all subdirectories and files within those subdirectories. And in this example at the top, inf means an infinite number of levels, or as many levels as there are to copy. So basically, all children subdirectories and files of this directory will be copied. And we could add permissions and all sorts of other attributes to these things, of course, again. So again, we can paste this code into the template, run it through CFEngine, and try this kind of copying. We can do more advanced things with files, but still files promises. Creating files as empty containers is one thing, but filling them with content is another. Copying files from one location to another is one way of filling it with content. Another way is to actually edit the file. And sometimes it's useful to edit a file if the file has already been partly maintained by somebody else, and we simply want to make sure that something about it is true, like in this case that a particular user has been added to the password file whilst not touching anything that was there before. I'll show you another example with a web server a bit later. So in this example, we're going to add some users to the password file and to the groups file. So this is user management. And the user files, these password and group files, of course, have this very special format in Unix, which is colon-separated tables, tabular files with colons separating the table. And so we've created these blue user-defined library methods for editing files that look like that. And we've chosen to give them just 3 arguments, and all of the other details are hidden. The arguments are the name of the user we would like to affect, and as you know, in these files, the name of the user starts the line. So the beginning of the line is the name of the user, and then there's a colon. So that's easy to identify. The second argument is the field in this table, the number of the field that we want to edit. In this case, the 7th field in the password file is the shell. And we're going to change the shell for Mark to /set this shell. So this is something you could try with the standard library. Everything is there, ready to use. You can try changing your shell to set this shell. It's not very productive, perhaps, but then you can change it back to bin bash again afterwards. Or you can try editing the password file by hand and see that CFEngine will repair the file and set it back to what it's supposed to be. We could have chosen to edit, for example, the second field, which is the password field. We don't really use that anymore in Unix, but we could set a password, or we could change the full name. We can edit any field in the password file using this kind of approach. Similarly with the groups file, if we want to add a number of users to the groups file, now there's a twist, which is that in the groups file we have colon-separated fields, but one of those fields contains a comma-separated list, which is the users that are allowed in a particular group. So let's suppose you want to add a list of users as defined in this top list to the group file for the group root. Well, the field number 4 is where the users get added, and this curly alpha notation, this curly at notation, is the way we write a list in CFEngine. It's made to look a bit like Perl, so the same kind of notation. And this this list is defined here at the top. So we're going to try to add user 1, user 2, and user 3 to the group file. When we do that, CFEngine will go to the 4th field. It already knows, because this is built into the standard library, that it's expecting a comma-separated list. So these details have been hidden in this interface, and it will be able to insert these users into this list without adding them twice. It will be able to, you can choose to have them ordered alphabetically or added to the end or added to the beginning. It's entirely up to you. This is all part of the configuration promise that you make. So if you then go in and delete one of these users, just one of them by hand, CFEngine will go in. It will see that that one user is missing, and it will add that one user back, either alphabetically or at the beginning or at the end, depending on what you've chosen. So this is how CFEngine is designed to work in all cases. It rolls you back into the golf ball hole or the black hole state, the ideal state. No matter which detail you changed, it has sufficient resolution to be able to repair exactly the thing that was broken. So here's an example how we might add a line to a cron file. Again, user-defined method called cronjob, which is in the standard library. And we've chosen to, of course, you know the cron file has many things that can be set. We've decided to keep the name of the command you want to execute, the name of the user that wants to have this cron job, star is the number of minutes and hours, I think. No, hours and minutes. So the hours that we want this to run, in this case all hours, and the number of minutes, so the minutes that we want it to run on. So we want it to run every hour, 5 and 10 minutes past the hour, or 5, 10, and 15 in the second example. And these will be added to Mark's cron file. Now there are many things that we've hidden from this, and lots of defaults that have been put into this method cronjob, but that's okay. We don't want to see those details in this high-level promise. We've hidden those in the library. And that's the flexibility that we try to give in allowing you to redefine these blue methods in CFEngine. So other things we can do with files include deleting, disabling, rotating log files. Again, these are all methods in the standard library. So to disable a file that we've created, this is part of a renaming promise. We can rename files. Disable was something that used to be in old CFEngine 2, and what it meant was we would rename the file to something else and change its permissions so that it couldn't be executable. Used to use that to disable certain programs like R shell that we didn't want people to use. This just will essentially rename this file and change its permissions. And similarly, rotating log files. If we have a log file and we say rotate 4, then CFEngine will take this file, change the file to file name .1. Whatever was .1 will become .2. .2 will become .3, and we'll keep exactly 4 of these, and when it reaches 4, they disappear off the end. So exactly like rotating log files, again, a common thing to be able to do with file management. Yet another thing with file management is the so-called tripwire behavior, where you can scan a set of files now, not a database, but you scan a set of files on the disk, and you look at their current state. What are their permissions? What are their exact contents? And you compute a cryptographic hash function of these files, which can detect, the smallest bit changes in the file. And then CFEngine will learn the current state of these things, and the next time it tries to verify that this promise is kept, it will compare the current state of the file to the one that it's already learned, and if they're different, it will create a warning, danger, danger, Will Robinson, file has changed, security, exception, whatever, and allow you either to respond to that in some way, create some kind of follow-up action, or simply have this as a warning. This, of course, is an important way of maintaining or of monitoring security on a local host. In CFEngine, we also have this idea of a neighborhood watch, which allows you to create clusters of machines working together to manage each other's machines. So one actually slightly implausible possibility is that a really good hacker could log into this machine, take it over, change some files, and then actually manage to change the database of hashes to cover their tracks. So they would be able to change important files and binaries and would be able to cover their tracks by changing files. But if we set up a neighborhood watch, small groups of machines can watch each other's hash files as well and detect if they've changed, making it practically impossible for a hacker to be able to cover all of their tracks at the same time, so that they would be able to monitor each other's progress. You can make an almost foolproof, essentially foolproof system for detecting intrusions using this kind of approach. One of the things that I often forget to mention with CFEngine, because it was actually one of the first things that CFEngine was used for back in 1993, is just to be able to execute commands, to schedule commands for execution. Of course, we have cron to do this kind of thing, but managing cron is kind of a dumb thing to do because every machine has its own file, so you have to edit each machine's file separately. Why bother to do that if you have a distributed system where you have a single point of definition? So you can define cron jobs or scheduled commands to be executed directly from CFEngine without touching cron by using so-called classes, which we'll talk about a bit later on today, to define the time and location at which we want a specific job to be executed. And then simply the affected object, the promise, is to execute this command, in this case this database update script, at a particular time and location. So this promise says it's about commands. We're going to execute a command. And it says that on Sunday at 4 o'clock in the morning, between 5 minutes and 10 past the hour, so between 5 and 10 past, when CFEngine runs during that 5-minute interval, on my host only, this command will be executed. So we've chosen one specific machine from all of the hundreds and thousands we're managing to run this one job. On the other hand, we could just say any : and have this thing executed on any machine, all machines in the network. And we can select exactly how many, which particular machines, which group, which class, at any particular time or location, and select very, very precisely where and when these things will be executed. Similarly, if we want to execute a job with particular user ID to limit the permissions, to limit the privileges of this job, then we can use the containment option in CFEngine using this standard library user-defined setUID option to set the username of the task which will execute this command. So we really have all of the flexibility we need to schedule jobs, tasks, batch jobs and tasks, collect their output, and email them back to us if we need to, or turn them, or send them to syslog, or add them to a log file. All of that management of commands, encapsulating, setting permissions, limiting privileges, all of that can be done within CFEngine, so we never need to manage the cron file ever again. Processes, of course, important thing to manage. So here's my example, killing the SNMP daemon. We can send a number of signals. In this case, we try to execute, or we try to terminate this thing politely. First, sig term is always good to set because programs can often respond and recover from that. Exit nicely. And then if sig term doesn't work for some reason, we can send sig kill for good measure. After, I think it waits 1 second before sending the second signal, which should kill the thing off if sig term didn't work. If we want to restart a process, this is now a collaboration between a process command and a process promise and a commands promise. I'll explain why in a second. So we look for a process matching HTTPD. If it's not running, then CFEngine will activate a restart class. In this case, we call it liftoff. And then we have another promise of type commands. If this class liftoff is true, because it's been set by this previous thing, then this restart command will be executed. And of course, there are different ways we can restart commands, but this is this is a modern approach to restarting commands. Why do we need two promises to do this? Well, because this is actually a command. We want to leverage all of those parts of the commands promises that we can make to be able to collect the output, to be able to run with certain permissions, to be able to limit the scope of the privileges. All of those things we want to be able to do. And instead of reproducing all of that inside processes, we simply point to a commands promise to avoid duplication of effort. So we've done files, commands, processes. We can manage storage. So look at attached storage and check how much free space is available. Again, this is a user-defined thing. This is not from the standard library. This is just a fake thing. It's going to warn us when the free space on this volume goes below 10%. We can mount file systems using NFS. In this case, this is from the standard library, and we give the name of the NFS server and the mount point that we want to mount this directory. Of course, the affected object is the first thing. The mount point is the affected object. So this is the mount point is home mark server home. The directory we are mounting from is the volume, the device name, which is home mark. So we've done files, commands, processes, disks or storage. Then another thing which is increasingly common today, of course, is package management. No self-respecting operating system today is without its own package manager, and this is a nice way of installing software. And I'm not suggesting that CFEngine is the primary tool for installing packages, but it's important sometimes when we're customizing machines to a specific purpose. For example, we do a bare metal install to some standard state or PXE boot to some standard state. Then we want to customize a machine to become a web server or a database server or a special application server. We need to add some more packages to the system to support that particular application. Or we want to remove certain packages because we're locking down a machine for high security work. So there are reasons to make delta changes to packages as well. And CFEngine can do that. As we saw in the web server example, CFEngine will talk to the local native package manager and arrange for the packages we add here to be installed accordingly. And this is the way a packages promise would look to do that. Those are all very simple examples of one kind of change, one kind of promise. This is the low-level bottom-up approach, configuring a particular resource. Well, that's not the way we always want to think about CFEngine. We would also like to be able to create bundles or subroutines of related promises that allow us to hide details. And this is an example of that. We define a subroutine as a so-called bundle of promises in CFEngine. So bundle agent means this is a bundle of promises for the agent. Blue means that this is a user-defined word. So we're defining this Apache Web PHP Apache bundle. And you see this contains a number of promises. It starts out defining some variables. It then explains some packages that it wants to have installed. Then it has some processes that it makes sure it should be running. So the web server should be running after it's installed. And then the commands, so processes and commands work together to ensure that this process is running. So this is how we can bundle up a number of related promises into a single interface. And you notice this doesn't have any arguments, so we can simply say Apache Web PHP Apache with no arguments, and all of these details are coded by default into this template. Another example, set up the SQL service, MySQL in this case. Exactly the same thing, define some variables, install some packages. In this case, we want also to check that a file is is present. Excuse me. In this case, the problem is that a lot of these packages install arrange to have the socket file of the server running in some strange place, which makes it unavailable to certain processes. So we can create a symbolic link to this to make it accessible. So this is not only installing a standard package from the operating system, it's also fixing a bug in the way the operating system chooses to install this package. And again, this is the kind of thing that a configuration management system would be used for. Managing that, documenting that bug for one thing, and then having it fixed automatically so that we can shove these details into the wall and out of sight. So those are examples of basic promises. These are the basic statements that you make in a CFEngine configuration. And two examples of how we put those things together to create larger bundles of services or interfaces, if you like, towards a service-oriented view of managing the system.